Did you hit record?
Yeah.
Oh, awesome.
Thanks. Okay. So today we're going to be looking more at functions. Okay. We're going to be looking at all different ways that we can represent functions. So just like the rules of the code, like we worked with yesterday, all the codes, the rules of the code, you can write a function in many different ways. And you can also write a rule for a function. So if you take a look at this table, it says right here what the rule is. So what's our rule for this table?
So it's like a machine. We're going to put a number in, and something's going to happen to it. If I put in a 0, I'm getting a 1. If I put in a 1, I'm getting a 2. If I put in a 2, I'm getting a 3. What's happening in the machine? We're adding 1.
Yeah, so we're gonna add 1. So we're gonna put in an x or an input. And if we input the 0, we're gonna add 1, and our output or our y is gonna be 1. And the same thing's gonna happen every time. There's a rule, and it's gonna happen each time.
And you have worked with functions already. For example, if I make $8 an hour, is that a function? For 1 hour, I get $8. For 2 hours, I guess. Yeah, that's a function. That equation, that calculation is what makes the function work. Whatever I put in, whatever hours you put in, you're going to get a different amount of money back. Right? Would you go to a job where if you worked 2 hours, you got $10, but if you worked 8 hours, you also got $10? Probably not. Right? Because who would want to work there? You want to make more money the more hours you put in. That's a function. So we start very technical. We're going to talk about the table and the equation, but don't get confused with the technical explanation. You already work with functions all the time. Anything that's a relationship, dollars for the amount of money I work, candy for however many houses you go to, those are all functions.
So we can also write an equation, and the equations have rules, just like the tables. We've taken tables before and made equations from them, right? We'd also made graphs. So look at the equation right here. Is this the same as this table? If we put in the 0, are we going to get the 1? Is the rule the same in the equation and the table?
Does that equation match the table?
How can we check? How can we prove it? How can we check that table and that equation have the same rule?
If I put a 0 into the equation, what do I get? If I put a 0 in for x, what's my y? If I put a 2 in for x, what's my y? Does it match the table? Is that what the table tells us? That x is 0, y is 1. X is 1, y is 2. Is that a match? Yeah. And what did you do to prove it? You substituted in the values. Absolutely.
Okay, so in the equation, just like in the table, our input is x, and the output is y. So after you input something for x, you're going to get an output. Whatever it equals is going to be our y.
And what does that equation look like? Think about what we were doing the other day with the zombie activity. What does that equation look like? What would we do with an equation like that? Think about the zombie activity. Y equals mx plus b. What format is that? So that equation tells us the slope and what else? And the y-intercept. Could you graph that line? How would you graph that line? What would you do? Because you are responsible on your exam for graphing that line. What would you do first? How do you graph it? First thing. Plot the y-intercept. Where does that line cross the y-axis? How do you know it's at 1?
The equation is at 1 right there.
Right, so that value on the end, that plus 1, that is our y-intercept. Okay, so we have 1 point. How do we get another point? We used our y-intercept. What else do we use to get another point? The slope. What's the slope of that?
That's
Where do we look for the slope? So we look at the x. We look for the number that's with the x, that coefficient. What's the number with that x? It's a 1. How do you know it's a 1 and not a 0? How many x's do I have there? 1. So we don't have to say we have 1 x. If you just show the x, you have 1 of them. So what's my slope? How do I move from that y-intercept? Rise over run. So if our slope is 1, what's my rise and what's my run? I'm going to go up 1 and over 1. Good. So notice that we're putting it all together. We graphed lines already. We did proportional relationships. We graphed lines with a y-intercept and a slope. Those were functions. Now we're just introducing what a function actually means. This isn't really new. Because you've worked with equations like this. We use scenarios where $8 an hour, how much they make after 1 hour, how much they make after 2 hours. You are actually working with a function rule. So this is not new. We're just adding a definition to what you've been doing. And then after today, we're going to go back to just working with functions, graphing them, comparing them, and doing more work with them. But today's more of like the what does it actually mean, big picture kind of day.
Okay, so let's take a look at this table now. What's the rule for this table? What's happening if you input the x? What's happening to give you that output of y? Take a look and think about it. What's happening?
There's a pattern. And the last one, we put a number in, we added 1. Is that my rule here? Am I putting in a number and just adding 1 to it to get my y? It's like a puzzle. Figure out what's happening. The same thing is happening in every relationship. What are some ideas?
Little bit. I mean, the last one was pretty straightforward.
This one's challenging, so we're going to give you a while. What's happening between x and y?
It might not just be one like operation. It might not just be adding or subtracting. There might be something else going on in there.
I think it's times 2 plus 1.
Times 2 plus 1. Let's see if she's right. We have -4 times 2 is -4 times 2. -8 plus 1 we get -7. Good. Let's try one more. We have 3 times 2 is 6. Add 1. 7. Yeah, it seems to be working. If it works for just one, do you think it's going to work for all? If there's a general rule. Okay. What do we think? We checked that it worked for one. Do you think that it's going to work for all of these? There's like a general rule for this table. What do we think?
So here's the problem. What if I came over here and I said, you know, I'm going to choose this coordinate. How did I go from 3 to 7? I added 4. So I think my rule is that I'm just going to add 4. Am I right? How do you know it's wrong? Can I just do 1 and say, well, that's what it is, we're done? What happens if I just add 4 to 5? Am I getting 11? Or if I add 4 to 16? Am I getting 33? So how many times do you have to check this? Your pattern. You found that pattern. Lauren, how did you know? Like, how many times did you check the times 2 and plus 1? How many times did you check that until you were like, I know this is it?
I tried it with all of them.
Say it again.
I tried it with all of them.
You tried it with all of them. So what if this last number here, instead of a 63, was a 60? Is that the rule? Is times 2 plus 1 the rule? No, because it would have to work for all of them. Great catch. That was a really good pattern to find.
Awesome. So what would the equation be for this table here? How can we write an equation for this?
So our output is going to be 2 times our input plus 1.
2x plus 1.
Is that an equation? You said 2x plus 1, which is a great start. What else do we need? Heads off the desk, please. Equals y. Absolutely, because that y is our output. So our answer, whatever we get, is going to be 2 times our input plus 1. Perfect. Could you graph that line? How do we start? What's the first thing we do to graph that? Y equals 2x plus 1. What can I do first? This is just repetition because you need to know how to graph. Y-intercept. What's the y-intercept in that equation? 1. So where do we put it? On the y-axis at the value of 1. Perfect. Right there. Then what? How do we get another point on the line? The slope. What's the slope? Someone said rise over run back here. What's our rise and what's our run? If our slope is 2. What's our rise and what's our run? For every 1x, what's happening?
Rise 2 up.
Good.
And 1
And 1,
to the side.
good, to the side. Every time I increase 1x, I'm moving up 2. So every 1x, up 2. Perfect. So that's our line. What do we know about every...
It's supposed to be straight up.
Yeah. What do we know about every coordinate on that table? Where will it fall? So they're always, all those points are going to end up on what?
The positive.
Well, yeah, they are going to, well, I mean, the -4, -7 is not. But the line that Miss K drew, actually now, it's not straight, but, you know, obviously with a ruler it would be. Every point on that table will be on that line because they all satisfy that equation. That's what points on the line are. They're the solutions to the equation. That's key. You need to know that. The coordinates are solutions to the equation.
Okay, so now we're going to take a look at a little scenario here. This table shows the number of dog licenses issued in the town of Palmer over a 5-year period. So when you get a dog, you have to have like a license for it.
I didn't do that. We tell my dogs all the time that they actually would get abducted.
Yeah, so that way if like you get lost or something, you know, and then also to show that they have rabies or that they have the rabies shot.
Yeah.
But anyway, so this is showing that how many dog licenses in a town called Palmer over a 5-year period. So here's the years it's saying is our input, and then the number of dog licenses are our output. So what's the relationship here? Do we see a relationship between the input and the output values?
Every year that passes, what's happening with our dog licenses?
Getting close to
We're getting, okay, so Lewis says that every time we increase a year, we're getting 25 more dog licenses. Is that true?
No, because no, 3 and 4 have the same.
So what's the problem in year 3 and 4?
They have the same output.
Which means what? How many dog licenses were
0.
issued in year 3?
the same number.
The same number. So is that a pattern? Like, do we have a pattern here? No, we did. Like, and we were at a good point. Like, we increased by 25, and we increased by 25, and then we didn't increase. We stayed the same. So can you say that there's a pattern there, or would you say no, there's actually not a pattern because it broke? There's not. Good.
Alright, so can we graph this? Can we graph this? What's the first thing we need to focus on when we're graphing? We have a graph just like this. What do we need to fill in?
If there's no pattern, do we have an equation? Why no? Do I have a constant slope? No, because why not? What's happening? What year breaks that constant slope? Yeah, the fourth year. I don't add in another 25. Okay? So if I don't have a way of plotting that, like y-intercept and that slope, how could you get a line here? How can you use the table to create a line? What could you do? So we have like 1 year, 75 licenses, 2 years, 100, 3 years, 1. How do we get a line out of that? Plot down the information. What information specifically? What information would you plot? The number of dog licenses and also what else? The year. What do you know about 1 and 75 in terms of the graph? How can I put 1 and 75 on that graph? Where would that go? What do you want to go by tens? Okay, so on the x-axis, do you want to go by tens or by ones?
What
We
is
have
our-
1 year, 2 year, 3 year, 4
What
year.
is our x-axis going to represent?
Is the x-axis going to be the years or the dog licenses? How do you know it's years? The x-axis is the number of years. And there's a reason why on this graph that it is the number of years and not the dog licenses.
The top one is X and the bottom one is Y.
Is it always?
Not always, but
How do you know that in this scenario, the years is definitely the x-axis? There's something up there that tells you it has to be the x.
this is moving by one.
It's not the movement because it's the years is the
Input.
because the years is the input. And remember yesterday when we learned the definition of a function, we said for every input there's one output. For every x, we get one y. Our input is our x. Good. So we know that that's years, which means the y-axis is the licenses. How do we put that information on the graph? How do you create a line if you don't have a slope and a y-intercept? Nakia said to plot the information. What does she mean when she says that?
To plot it so we can get slope of
How do you plot that? So you find where the year and the licenses do what? Where they meet. Okay. So what coordinate, that's the word here, what coordinate do you want to plot first?
on one and go up to 70.
Right, 1 and go up to 75. So we'll just label this however we want, by 25s. 25, 50, 75. So that is a coordinate. X is 1, Y is 75. Can I keep going? Could I plot every single point on that line? What do we think?
2 up to 100.
2. How about if the years is 3? If X is 3, what's Y? 125. Good. What about if X is 4?
125.
5. What about if X is 5? How do we connect those? Is that linear?
No.
How do you know that's not linear? By looking at it. It's not a straight line, right? It is like for a portion, but then it's not. And how do we know if we're looking at the table that it's not linear?
So it had 3 and 4 had the same output.
Yeah, yeah, it's not linear because we're not growing at the same rate. Okay, so you do need to understand how to graph, but it's not always going to be slope and y-intercept. You can always plot the points on a table. Sometimes you're given a table and students want to overcomplicate it and try y-intercept and slope. You can just plot the points. Okay, that is possible. Good.
All right. So here we plotted our points. They're still there. So would there ever be one year that is assigned two different quantities?
So is it possible that like in year 6 we're going to issue 75 dog licenses and 150 dog licenses?
No.
Does that make sense? Why doesn't that make sense?
Because it needs to be the same, it can be different output but not same input.
Okay, so explain that in a real scenario, right? And I feel like maybe my question kind of laid it out that way. In year 6, how many possible answers could you give me if I said, how many licenses did you issue in year 6? Yeah, you're only going to give one answer. There's only one answer there. It's not like you're going to say 50 and 120. That you would just say 170 if it was two different amounts. So is that a function? Is that relationship, even though it's not linear, is that a function? Why yes?
Because every one input is still an output.
How many? Because every year we only have one amount, one output. Good, so that is a function, even though it's not a straight line. So do functions have to be straight lines? No.
So what if for year 6, we also had 150 dog licenses? Is that still a function?
Yeah.
Can we plot that point?
Go to 6 and up to 150.
Yeah, so why is that still a function?
Because there's only one value for each year.
Because there's still only one output for each input. There's one value for each year. Good. Okay, so now we're going to talk about a different scenario, still with dogs. Dogs age faster than humans do. Some people claim that dog years are a function of human years. Have you ever heard that? That like dog years are different than human years?
You've never heard that?
Yeah.
That like if you have a dog that's like a year old, they say 7?
I have cat myself.
I feel bad for you. Dogs are way better.
I have both. Okay, so on the blank graph, we're going to label the axis and then plot the curve there. So take a look at this table. So this is saying the input is human years and the output is dog years. So what is the rule here? Is there a rule? Is there a rule here? Can we find it?
For every year,
For every, what kind of year?
for every human year, dog is 7 to 4 years.
The dog, what? I just can't hear.
The dog is 7 years.
Yeah, the dog, so for every one human year, the dog is 7 years. So I heard Giovanni over there saying, we're multiplying by 7. Oh, you didn't say that? You said that. Oh, sorry. Sorry. I just heard it in that direction. Okay, so we're multiplying by 7. Good. So that's our relationship between the input values and the output values. We have an input value, it kind of goes through like a machine, and by the end, when it comes out, we multiplied by 7, and it gave us our answer. So if we put in a 1, it goes through, we got 7. Put in a 2, it goes through this machine, and we got 14. It's multiplying by 7 each time. Good. So how can we graph this? What can we do to graph this?
Is there a constant pattern? And it's the same throughout? So if we graphed this, would our line be straight or curved? Because what's happening every time we're increasing an x value? How are we moving?
7.
We're moving 7. Okay, so how would you graph that? Where could we start? What would you do?
Plot the
Okay, we can plot the 1 and the 7. If the input was 0, what would the output be?
0.
How do you know? Just common sense, how do you know?
Because both zeros.
If a human hasn't been born yet, and they're like 0, like before life starts, right at the beginning, what's the relationship with the dog? Is the dog alive yet?
No.
No, so both would be 0. Is this proportional? Yes, good. Okay, so we plotted 1 and what?
And 7.
1 and 7.
How do we want to label our y-axis here? Good, by 7.
Good idea.
1, 7, 1, 1 down. 2, 14.
Do I have to plot the points, or could I say for every 1 over, I'm going to go up 7? Could I use slope and y-intercept here? Why yes?
So it's a basic is the unit rate.
Because the slope is our unit rate. For every 1 year, how much is the age increasing? 7. So when I go from 2 to 3, my y is going to go from 14 up to 21. I can use the slope and y-intercept here because that pattern is consistent. Good.
So can we write an equation for this? Y equals, we're off to a good start. Good. 7.
job.
Plus 1. No, plus
What's our y-intercept?
0.
So do we have anything to add there?
Nope.
No. And again, if you have a proportional relationship, there is no y-intercept. It's 0. Well, there is, but it's 0. So a proportional relationship will never have that like b value added on. That would mean your line's crossing somewhere not at 0, 0. Perfect. Good. Oh, we did that.
Oh, yeah, we already did that. Okay. Oh, before we actually do the table. Sorry, the out of order. So first we're gonna work
Oh,
on this together.
I meant to cover this, but like I wasn't able on my computer to add a shape, so I duplicated it, so I didn't have to zoom it out. So there's 3. Let me explain all my numbers.
Okay, so for number 1, you're gonna make a graph for a function in the table. For number 2, you're gonna complete the table. It just says y equals 2x plus 5, and then these are the x's on top, and then that's the y. Where you see that the f in parentheses x, that just means y. You don't have to worry about that right now. So y equals 2x plus 5, and then the x's, and then you're gonna complete the table for the y's. And then for number 3, you're gonna take a look at this graph, and it shows how many cookies Julia makes over 9 years. So you want to find out how many cookies will Julia make in 9 days. Sorry, and in 7 days. Okay. So you can work together on this.
All right, so you're gonna hand this in. You're gonna have 5 minutes in your table with everybody's name on it, handing it in for a grade, because we need a little bit more activity going on here. So name on the top of a paper, we're gonna put 5 minutes, and all of you are going to collaborate and submit.